Welcome to qnawire.
Okay, I've got to redraw the steroid right quick. Parallel, parallel, parallel. And then we'll start drawing some of this in. And then parallel, parallel. And I don't think this matters too much, but I'll draw that on there. Let's highlight the carbons in question. This is 3 and 11 and 7 and I guess 10. 10 has a CH3 and 13 has a CH3. And let's draw in these hydrogens that I happen to draw in for some reason. Great. Okay, what are the questions? The substituent on C3 that is cis to the C10 methyl group will be axial or equatorial. Okay, C10 methyl group, this is pointing straight up. It's also axial. So if it's cis to the C10 methyl group, that means it's on the same side of the ring. Right? So what we've got to determine is that carbon 3 is something on the top of the ring, axial or equatorial. At this particular position, these are the two choices: axial on the bottom of the ring or equatorial on the top side of the ring. Right? So if it's cis, it should be the upper of the two choices, and it would be equatorial. So the answer to A is equatorial. Maybe I'll just put an A here for a substituent. I don't know. Okay, a substituent on C7 that is trans to the C10 methyl group. Okay, so C7. What is axial and what is equatorial? At this particular position, just like the hydrogen here, axial will be down below the ring and equatorial will be up. Right, so A, it's supposed to be trans, which means if it's trans to C10, then that means it's going to be below the ring, which in this particular position on carbon 7 is axial. I mean, hopefully you see the what's going on here. Okay. And they kind of show, I see what the purpose of these hydrogens is. This hydrogen is analogous to this substituent, and this hydrogen is analogous to this substituent. And I'm going to guess that this hydrogen will be analogous to, let's see, what they say on carbon 11. Nope, not at all analogous. So I don't know why they put those hydrogens there. Whatever. Okay, trans to C13, which means not on the same side of the ring. So on C11, an axial carbon would, or an axial substituent would be straight up, and an equatorial would be down. And draw that very well. It would be, and not quite. I'm not drawing the angle quite right. There we go. Right. So if it's trans to this methyl group, it would have to be the lower of the two, which in this case would be equatorial. Right. So it looks like we're equatorial, axial, and then equatorial. And if you're confused, I just wanted to point out how if you're wondering how I knew what angle to draw this out, check that these two lines are parallel with this line, right? Likewise, these two lines are parallel with the equatorial groups here. And these two lines are parallel with the equatorial group here, as well as here, right? So it's all just like, if you draw out every single substituent you should end up with like a bunch of sets of 4 parallel lines for each cyclohexane. Like just a quick example. All right, so these are the equatorial groups. Okay, equatorial, equatorial, and equatorial, and equatorial. And then everything axial is also parallel. Just a little tip. Okay.